programmers of the world should feel a burden to think about how their software is being used. Now, I will say that you can't always stop people from using your software in some bad way, especially given the frequency of open source software, which is an increasingly popular thing. But this brings me to your question specifically. Open source is a wonderful thing. It's free. You get to go there and use other people's software. It gives some satisfaction to the people that shared their software that somebody else used it. However, often that open source is not very well supported. It might be one person or half-time or something. And so there are bugs in the open source software that don't get attended to. Maybe you reported on something called Log4j, which was a piece of software that was used for logging events. It had a bug in it that was exploitable, and that bug had probably been around for more than a decade, maybe even 2 decades. So I do worry about the ethics of software and attention to weaknesses and vulnerabilities that we should try to eradicate so that people who are relying on the software are not at risk. There's another element here, and it has to do with how you apply the software. And let me be specific about artificial intelligence and machine learning. Those of you who have tried some of the chatbots will resonate with this story. Some time ago, I decided to test one of the chatbots by asking it to write an obituary for me. I know that sounds terrible, but I thought, well, the obituary format was probably ingested into the large language models because there are lots of obituaries on the internet. People die every day. People write obituaries. And I thought, well, there's probably some information about me, at least on Wikipedia, for example. So I figured that the chatbots would have enough information to write a reasonable obituary. And indeed, the chatbot produced an obituary as you would expect. It said, we're sorry to say that Dr. Cerf passed away. And actually put a date on there, which made me very uncomfortable. It was in the future, but, not very far into the future. And then it summarized my career, and then it had a list of family members. But it conflated things I did with things other people did. And when it got to the family members, it made up family members that, as far as I know, I don't have. So I was asking myself, well, how can this happen? And a cartoon answer, remember, I'm not expert here, but a cartoon answer is that when you're building the chatbot and when you're training it with the text, you remember how reinforcement learning works. You ingest all this stuff, where they're called, the phrases and words that it ingests are called tokens. And so you build this gigantic complex network of the relationship among tokens. The question is, how often does this token show up in connection with that token? And you build this very complex set of relationships. And then the training part is you give it an assertion or a statement with holes in it, and you ask it to fill in the blank. And you grade it on how well it filled in the blank. And as you grade this thing over and over and over again, the parameters, the various terms and parameters of the system get values that determine how the output is produced. So it's easy to see that the chatbots, the machine learning models that the chatbots incorporate, are losing context. They don't know where some of these phrases came from. They don't know that this phrase or this token came from this bio, and this other phrase or token came from a different bio, but they were on the same web page. And so it sort of mixes them together. It doesn't know that there was a context that should separate them. So there's work to be done to get the chatbots and the large learning models to know more about the context of the things that they've ingested. And the reason I tell you that story is that some in Europe, for example, there has been some focus of attention on applications of large learning models, large language models. And the idea is, how risky is the application that they are being used to implement? So if it's just storytelling, that's fairly low risk. It's just entertainment. I even asked one of the chatbots to write a story about an alien that invaded my wine cellar and was living off of my Cabernet Sauvignon. And it wrote a nice little story about this Martian who showed up unknown to me until I happened to notice some empty bottles in my cellar. So it wrote a nice little story. That's a low-risk application. But if you're asking the chatbot to give you financial advice or medical diagnosis or medical treatment, that's a high-risk application, and we should be very careful not to suggest to people that they can use these kinds of chatbots for that kind of advice. So we have this layering of risk. And for high-risk applications, there should be a great deal more attention paid to, ethical attention paid to whether that is a reasonable kind of application for these to use. So I'm sure you're all aware of the Turing test. Now, maybe some of you have been here when I told about what I called Turing test 2. This is not quite the same as the test you're asking for. This is the test where a piece of software is trying to figure out whether it's talking to a bot or a human, because it doesn't want to talk to the bot. It's a waste of its time. You know, I don't want to show advertisements to a bot because it won't buy anything. So that was Turing test 2. I think you're asking for what's Turing test 3. And I am not 100% sure that I know how to do this. Remember when you were in school, and let's say you were taking math classes, and the teacher said, here's the homework, but please show your work, as opposed to, here's the answer. And if you have to show your work, that means you have to show that you actually can think logically through to the solution. Here are the steps that I took. Maybe there's something like that that would help us figure out whether it's a bot we're talking to or a human being. Of course, the problem is some humans don't know how to think logically, and so they can't show their work because they don't know how to do it. The chatbots can sometimes answer questions and even show their work, but often they get it wrong, particularly arithmetic. However, of course, the researchers have found a way around this. If you're familiar with how some of the chatbots work, you know that after you have this text exchange with them, some of the chatbots are being outfitted with the ability to go to other applications to do symbolic mathematics, for example. And so if the bot has figured out that your question requires a computation, there are interfaces, application programming interfaces, APIs, that let the chatbot go and get an answer from a computational tool, or maybe get an answer by doing a search on the web, or get an answer using some other application. So the chatbots are getting smarter in the sense that they can exercise tools that you and I would use if we wanted help with symbolic math, for example. So from my point of view as a technologist, I actually like this because I like the idea of getting a convenient tool that I can have a dialogue with, also exercising these other tools to expand its capability, its functionality. The problem, of course, is exactly the one you raised. It makes the tool appear more and more human. Now, it's very important, I think, to distinguish between what I will call the verisimilitude, nice 50-cent word, the verisimilitude of human discourse, which is what the chatbots do very well, because they've ingested well-formed text and content, and of course they emulate what that looks like. I would distinguish between the verisimilitude of human discourse and actually having a conversation with a human being. And I think it's going to get harder and harder to distinguish between the two. And this gets to an interesting question. Maybe in order to be sure that you're communicating with a human, we have to be able to authenticate ourselves strongly as people. And now the question is, will the chatbots get the same ability to identify themselves as an individual? And there are some researchers who actually argue that the chatbots should be identifiable individually so that we know which chatbot we're interacting with and also know that it's a chatbot. Of course, there will always be somebody that doesn't follow the rules, puts a chatbot up, and pretends to be a person. If all the ills of the internet seem to boil down to one thing, people. If we didn't have any people, we wouldn't have these problems. but then it wouldn't be interesting. So here we are. Turing test 3 is probably going to require a certain amount of authentication because, you know, there's another expression in history which says history is written by the winners. And that means if the chatbots are the winners and we're not, that's not a good sounding outcome. Actually, perhaps we will be lucky and the histories written by the chatbots will be better than the histories that we might write as people, because we may have biases that the chatbots don't have. We've also heard quite reasonably that chatbots are trained with material that could have built-in biases already. And so that's another big test that we have to do. How do we know whether a large language model or any machine learning model has a bias in it? In order to discover that there's a bias, you have to be able to imagine how that bias would manifest. Otherwise, how do you test for it? And so sometimes the failure to detect bias in these large language models or machine learning tools is because we can't imagine what that bias might look like. Could I just take a minute, not to dwell on the large language models, but to go back to the kinds of machine learning models that have turned out to be very practical, because I don't want you to go away thinking that all machine learning is bad or harmful. So I've told this example before, so I'm sorry if you already heard it, but we're very proud of this one. In our data centers, we have a lot of computers, and they consume a lot of energy, and they get hot, and you have to cool them off or they don't work. So we have an elaborate cooling system that often involves pipes and valves and pumps to move cold water through and blow cold air through the system so the computers can keep working. And for a time, at the end of each week, a human being, an engineer, would look at the power requirement for cooling the data center and try to adjust the plans for the cooling system, the pumping rates and which valves were open or closed, to reduce the amount of power required to cool the data center. So we were trying to be efficient. Somebody said, this is some time ago now, that we should consider training a machine learning model with the objective of reducing the power requirement to cool the data center. So it's a very clear objective function. How much energy did we use to cool the data center? So they spent some weeks training a machine learning model against this objective, which is to reduce the power required to cool the data center. And after they got it trained, it saved 40% of the power requirement to cool the data center, which is not bad. So there's an example. Of course, we went off immediately and started programming that for all the data centers. So that's an example. There's another one, which I'm sure you're familiar with. One of our sister companies is called DeepMind. And they figured out, using a kind of a game that humans could help with, how proteins fold up that could be generated by DNA. And so they tested this idea, and they generated the molecules, the folded protein molecules, for about 88,000 proteins. And then they proceeded to go through all the possible combinations of DNA protein generation, 200 million of them. So we now think we know the shape of 200 million proteins that could be generated by human DNA. Now that library is really important because we might be able to discover treatments, for instance, using small molecules that would interfere with some sequence of disease or might enhance some capability that we would like to keep us healthy or healthier. So that's an example of machine learning that's quite positive. And there are lots of other examples like that. But some of them do translate into the chatbot world, which we worry a bit about. Well, my ability to predict the future is demonstrably poor. For example, I'm the guy that thought that 32 bits of address space for IPv4 would be enough, and of course it's not. We need IPv6 now. You can help me, by the way, by repeating that we need more IPv6. Please ask your internet service provider, when will I get my IPv6 address? I would say that, first of all, with regard to 5G and 6G, if you are tracking the industry, you'll notice that the 5G investments may not have produced the expected revenue gain that a lot of the telecom companies were hoping for. But there is an interesting architectural element of 5G which is expanded in 6G. What is that? You know, the base station, which is what normally connects your mobile to the rest of the network, in the 5G and the 6G paradigms can have computing capability associated with it. It's called, there's a name, it's called the MEC, which is an edge computing capability. Why would you want to have a computer between the cloud and your mobile or laptop? This is sort of an intermediary thing. The reason has to do with latency. And there may be some applications that require very low latency, certainly real-time kinds of video games. But an example of something that needs low latency is the turn-by-turn driving instructions, or when Uber, for instance, if you use the application, you'll notice that it tries to track where the car is that's coming. That requires very low latency in order to keep real-time track. So the idea of putting some computing at the edge between the users and the cloud is one of the things that the 5G and 6G architecture offers. There's something else that it offers, which I have not had too much experience with yet, and that's the fact that the application may be able to tell the base station how it wants to use the communication system. It may want certain characteristics for, you remember the Metcalfe, if you heard his lecture and talked about determinism and the probabilistic nature of Wi-Fi and Ethernet. There is a trend towards determinism. That's just in 5G and 6G, your devices are told when they can transmit. And in fact, you have to have really high quality timing available to do that, from GPS typically. And so that's not a probabilistic thing at all. It's very deterministic. That can turn out to be very useful when you're looking at low latency kinds of applications. So I am imagining that when 6G shows up, we may end up using it for more deterministic kinds of services, in addition to the local computing capability. And what is maybe even more surprising is that the 5G and the 6G world have tended to refer to outdoor communication. It's, you know, whenever we're driving around or walking, as opposed to indoor, which is where Wi-Fi shows up. It's very possible that indoor 5G and 6G architectures will turn out to be very useful, especially if you're building a manufacturing plant and you have all kinds of equipment, but over time you're going to move it around. The last thing you want is a whole bunch of wires. And so if you can use 5G and 6G with a disciplined kind of application, you may be able to build a very flexible manufacturing plant, or maybe it's a warehouse with the little automatic robots going around filling the orders. Internal communication, private networking effectively, may turn out to be one of the outcomes of the 5G and 6G design, having nothing to do with the outdoor applications. I was just out at the Jet Propulsion Laboratory 2 weeks ago with my colleagues who have been working on the interplanetary internet since 1998. So this is now 25 years in development. We're very excited about the Artemis mission and the return to the moon. We're seeing, for example, the European Moonlight effort and the American LunaNet effort. There's a lot of collaboration between ESA, NASA, JAXA, and CARI, the Korean Space Agency. The people who have been invited by NASA to provide commercial communication services are, just as you say, thinking 4G and 5G. This is a little weird in a way, because in order for those to work, they do have to get very good timing information for the reasons I mentioned before, that it's a scheduled communication. Your mobiles are told when they can transmit. You can get a GPS signal on the moon. It doesn't work on the other side because, the moon is in the way. So this isn't going to work everywhere. So I believe that what will happen is that the folks who put up those systems will quickly discover that even if it sort of works on the moon, because the distance between the Earth and the moon is only 250,000 miles, it's about 2.5 seconds round trip time, that will not serve very well when we get to Mars, which we hope will happen sometime in the 2030s. So we at JPL and at NASA and ESA and JAXA and so on are looking very much at our bundle-based protocols, which is a new protocol design that will allow for communication in a highly variably delayed and disrupted environment. And so the 4G systems could be part of that. In the same way that they're part of the TCP/IP world today, they can become part of the bundle protocol world by a simple change in software. I'm sure you've all heard this expression. It's a simple matter of programming to add these new features. Of course, there's nothing simple about programming, but nonetheless, that's what I hope will happen. Okay, so are we, in fact, this is a very good question, are we losing freedom or losing privacy is the concern. And I think the honest answer is yes, that in general, more of our lives are more visible now than ever, and often completely out of our control. I've told stories in previous press conferences about someone with a mobile taking a picture of you in front of the pyramids, which you've asked for because you wanted to document this, but someone else is in the picture. And you know, that person didn't ask to have their picture taken, but you put it up on the web anyway. And you know, someone discovers that that person was in Egypt on a certain date, except they told a friend that they were somewhere else. And so now they're exposed for having misrepresented where they were. So I think this visibility is with us, and I don't think that's going to go away. So there are some things that it's very hard for us to counter individually. On the other hand, there is information that we could justifiably argue should be protected. Our identities, our financial information, our health information. In the United States, there is a lot of legislation associated with protecting medical information and financial information. These are called highly regulated industries. And I would guess that the same argument is true here in Europe as well. So we know that, that we can provide incentives to these highly regulated industries to protect people's privacy by telling them that if they don't do that, there will be consequences. And there have been some serious fines against the companies that have failed to protect privacy to the extent that that's reasonable. Now, there is something that you should think about for a moment. Some people will say, well, I really don't like the idea of having to strongly authenticate myself because it takes time and it's an extra burden. And yet you should want this for certain kinds of applications. You don't want someone else to be able to pretend to be you and take actions on your behalf that you didn't authorize. So strong authentication is actually our friend when it comes to protecting our interests. So two-factor authentication, for example, is important. I won't bother to take my laptop out, but I have a tiny little piece of electronic equipment that slips into the USB port. And when I need to strongly authenticate myself, the little light goes on and I tickle it, and it sends a cryptographic exchange to the website that I'm working with. And no one else has that little piece of chip. It's me. And if I lose it, it's okay because they don't have my username and password that makes the chip useful. But the chip reinforces my identity. And of course, I carry several of them just in case I lose one. I have them registered. So those are things that we can do to protect our safety by making it hard for someone else to pretend to be you. The other side of this coin is, why can't I use the system anonymously? And there are applications for which you should not have to identify yourself at all. You shouldn't have to identify yourself to do a Google search, for example, and you don't have to. We don't insist on anything like that. You might get better service if we know, which account you're on, but that's up to you. So I think we're at a point now where people are more sensitive to the concerns that you've expressed, and I think there is pressure on the companies, including mine, to protect people's safety and security and privacy. And the incentives are that if you don't do that, there may be consequences that are expensive. Besides which, you will drive your customers away if they don't feel confident in the service that you're getting. But I will say, though, that it's a significant challenge at this point, and it continues to be. You know, the notion of a discipline is really just an artifact. We use it to structure the university environment, so we have departments and we have schools and so on. One of the interesting alternative structures is where you create an institution within the university that's focused on particular problem areas. So it might be on microbiology, or it might be on mechanical engineering, or it might be on something else. But it's attempting to achieve some objective that requires multiple perspectives and what we would call multiple disciplines. So Stanford University, for example, although it does have departments and schools, also has engineering institutes that are focused on particular problem areas, and they invite people who we would say come from multidisciplinary origins to look at the problem. I'm a huge fan of drawing as many different perspectives as possible. Sometimes it's really surprising what happens when people of who've been trained in different disciplines work together on a particular problem. Usually it's a getting started part to this. It's sort of like remember the old automobiles that you had to hand crank to get going? Well, sometimes when people working in different disciplines use the same words to mean different things. Here's an example. ATM could either be asynchronous transfer mode or automated teller machine. And I have had conversations that started out with two people thinking ATM meant different things, but they didn't know that because they were using the acronym. I've been involved in those discussions, and only part of the way into the conversation I suddenly realized, oh, they're not talking about asynchronous transfer mode. They're talking about these things that issue paper, money. And that made the conversation a lot easier once we figured out what we were talking about. So I'm a big fan of this sort of multidisciplinary work. And I like the idea of universities deliberately institutionalizing that so that you don't have to be a member of a particular department in order to participate in the institutions of the school. I'm convinced that the problems we have today will require a lot of different perspectives in order to solve them. They just get more and more complicated. That's why the computational X idea is so important, because computers can draw people together.